Hey everyone, these are the polar FRQs, okay? I'll be going through the FRQs as much detail as I can just to give you an idea of how things work, only because I know you have the solutions, the scoring guidelines, Ask Mr. Calculus, so this is just one more added layer in case you needed some support there, okay? All right, here we go. So there were 5. Here is the first one. So here, notice how we already have the picture. So there's no need to put your calculator in polar form. You could just keep it under function there, okay? Okay, so r equals 2, r equals 3 plus 2 cosine theta. So r equals 2 is definitely that circle right there. And this cardioid right here is r equals 3 plus 2 cosine theta. Okay, they tell me where they intersect, which is 2 pi over 3 and 4 pi over 3. We'll talk a little bit about that. Let R be the region inside the graph of r equals 2 and also inside the graph of r equals 3 plus 2 cosine theta. Shade it in the figure above. So here they don't leave any guessing to it. They tell you exactly what to find because they shaded it. All right. So this is what's a little bit tricky regarding part A. When you start on the positive x-axis, remember we're going in a counterclockwise direction here, right? So when you're sweeping out, notice how you're hitting the circle starting at 0 radians, okay? And it'll eventually stop right here, which is where they intersect, which happens to be at 2 pi over 3. They mention it right here. Okay, so often in these polar problems, you can play symmetry, which saves you so much time. Here's what I mean. That orange area right there is going to be 1/2 r squared. So in this case, it's 2 squared d theta from 0 all the way to 2 pi over 3. That's the orange part. But what I want you guys to see is that is the exact shape that I have down here. So I can double it by multiplying by 2. It's kind of like when you were dealing with those petals in the rose curves. It's the same logic. Since we see some symmetry from 0 to 2 pi over 3, we notice that same shape at the bottom. We're actually going to double it there. Okay, so if you notice, we have everything shaded except for like this area right here, right? And even then, there's a little bit of symmetry right there too. So let me go ahead and kind of get rid of a few things so that you guys can see it a little bit better. So if I can figure out, remember that this is 2 pi over 3. I know that this right here on the unit circle is pi. So I'm going from 2 pi over 3 to pi to get this little slice right here that I'll color in. Okay, so I'm going to show you here. I'm going to go ahead and add 1/2 integral of r squared, which happens to be 3 plus cosine theta squared d theta. I'm going from 2 pi over 3 to the far left, which is pi. That gives me the upper purple shape, but notice how this bottom blue shape is symmetrical to that. So what I could do is I could actually double it by symmetry. And then this here just becomes a quick plug and chug problem, which you guys can figure out there. All right. On the scoring guidelines, some people tend to flip out because they see the 2/3 pi 2 squared. What the AP reader or whoever made these scoring guidelines did was they noticed that that orange shape, I'll color it in again one more time, is actually a part of a circle. So they just use the area of a circle, which is pi r squared, and then they took a sector of it. So they did 2/3 of it. 2/3 pi of 2 squared. That's basically all they did. They took a sector of it there. I personally do not recommend that because it kind of ruins the flow and the pattern. I think this is a little bit easier to understand there, okay? Oftentimes you will see symmetry play out. So make sure that you guys keep an eye out on that, okay? And whatever you get there, make sure that you guys round. This is probably easy enough to type out without using any Y1s or Y2s, but you're more than welcome to do so, okay? All right, here's part B. Part B, they're asking you about a particle moving with some type of velocity along the polar curve given by r equals 3 plus 2 cosine theta. That's the cardioid there, the one that kind of looks like a weird knot circle. They tell you that this particle moves. I think I skipped the part. Okay. Has a position at x comma y at time t with theta equals 0 when t equals 0. So here's a given condition. This particle moves along so that the dr dt is the same thing as dr d theta. Find the value of dr dt at theta equals pi over 3. So there's a lot of jargon here, okay? So here's what you do. It's very straightforward with particle motion and polar curves. You have r equals 3 plus 2 cosine theta. What you want to do is you want to find dr. So we're going to write the differential. So the differential of 3 plus 2 cosine theta here is negative 2 sine theta d theta. Okay? So since we're trying to find dr dt, we're going to divide by dt, and we're going to divide by dt here. Okay? So what am I missing here? dr dt is equal to dr d theta. What am I missing? Oh, okay, my bad. And I'm doing this in real time so you guys can see me struggle a little bit here. They're asking us to find dr dt, but then they tell us that that's the same thing as dr d theta. A lot easier than I expected. So dr is equal to negative 2 sine theta d theta. And since I'm finding dr d theta, aka dr dt, you notice that these cancel out. So dr d theta is really negative 2 sine theta, but specifically we want to evaluate at pi over 3. So theta is equal to pi over 3 here. So you could either plug and chug there, or you could let the equal is equal play out. You could just leave it just like this if you'd like. But they do tell you to interpret your answer. So I guess knowing that we have to interpret, it's probably better if you crank it out in a calculator or understand that this comes out to something negative. Okay? And this is where we had to interpret back in delta math. dr d theta. So dr is less than 0. So we're talking about the radius or the pole here. So if dr d theta is less than 0 and r, if we were to evaluate at pi over 3, I could tell right there that r definitely comes out to something positive. I don't know exactly what, but I know it's positive. Since r is positive at pi over 3, you're somewhere right here. But since dr d theta is negative, that means you're going to move let's see, wait, hang on. You're going to move, I'm brain farting here. If you're positive. Okay, so if dr d theta is less than 0, that means r is decreasing. So that means you're actually heading towards the origin here. Let me double check. Oh, yay. Moving closer to the origin since the derivative is negative and r is positive. We did a little bit of that delta math there, okay? Okay, I'm running out of space here. Let me go ahead and clear this. Hopefully it doesn't clear everything. Okay, cool. Here's part C. Okay, for the particle described in part B, dy dt is equal to dy d theta. Find the value of dy d theta at theta equals pi over 3. Okay, so we have a y involved. So I know that way back y is equal to r sine theta. Okay, and I know that r in this case is 3 plus 2 cosine theta. So I'm going to plug that in. So I'm trying to find dy dt, which is the same thing as dy d theta. So I just need to find the derivative. You know, half the battle is just knowing what they're asking for here, okay? So this here would require the product rule. So we'll take the first times derivative of the second plus the second times derivative of the first, which is negative 2 sine theta. And then we're going to go ahead and evaluate that at pi over 3. And normally I would just plug it and leave it, but they're also asking me to interpret. So I'm going to kind of work this out a little bit here. So evaluating this at pi over 3, oh gosh, this is going to be 3 plus 2 times the cosine of pi over 3 times the cosine of pi over 3 plus the sine of pi over 3 times negative 2 sine of pi over 3. Okay. Instinctively, I would use a calculator because there's a lot going on here, but let me see if I could kind of figure this out. Cosine of pi over 3 is 1/2. So that's 3 plus 2 times 1/2 times 1/2 plus rad 3 over 2 times negative 2 times rad 3 over 2. You know what? Now that I'm looking at this, I would definitely use a calculator here, okay? I'm going to go ahead and cheat a little bit just to see what the sign comes out to. So dy d theta comes out positive. So remember, you also have to check out what's happening with the y here. So back up here, you would have to plug in what pi over 3 is and evaluate there. And I'm going to cheat a little bit there as well. Y comes out positive. So if y is positive, so let me just give you an example here. If y is somewhere above the x-axis, that's where y is positive, and dy d theta is positive, that means that y is increasing in value, meaning it's moving upwards. So that means it's moving away or further from the x-axis. Ah, there you go. Okay. So you'll notice, even if you did get parts B and C, getting 4 points out of 9, that's still a good chunk of your points there that you can get. And you're still in good shape to passing that exam, okay? All right.